All right, it is 2, so I want to honor those of you that are here on time and dive right in. So I think most of you watching will have seen the intro video and the first little project I did on Scratch, but I wanted to try something with you live so that you had a chance to answer questions, ask questions, I'll answer questions. And I also wanted to do something live where I'm figuring it out as you're watching me figure it out. So this is something I've done a long time ago, but Scratch has changed a little bit since then. So I'm going to see if I can remember it, or if not, if I can figure it out. And what I wanted to do today is a project I often do with my students when we first start coding, and that is to code drawing shapes. So shapes is something we learn about, especially in the younger years in primary. But we also continue to learn about angles and all kinds of things to do with geometry and shapes, so it can really connect directly into math. So we'll see what we can figure out. So one thing I have figured out is that down here in the bottom left-hand corner, there's this little plus button, and that lets you bring up a bunch of extensions that you can add in, extra things that you can do with Scratch. And some of these are going to look familiar if you have some of the coding techie toys like Makey Makeys or Microbits or Lego Mindstorms. So these let you be able to use Scratch with those things. But for today, I wanted to try this pen, draw with your sprites. So I'm going to try that. Awesome. So I've noticed now that I've clicked the extension, now I get this pen section down here. You know what? I'm gonna make my mouse a little bit bigger so it's easier for everyone to see. While I'm doing that, yes, Carrie, I will supply. I have been supplying this past year. I actually supplied for 1 day, and then I got right into an LTO for the full year, which was great timing, actually. Didn't mind that at all. Sorry, I'm just trying to find my settings where I can make my mouse nice and big for you. There we go. All right, now you can see it a bit better. Okay, so just looking at my pen blocks: erase, stamp, pen down, pen up, set pen color, change pen color. Okay, so knowing I have those blocks, I want to use my Scratch the Cat and try to draw a shape. So I'm going to start out with a square. So I always start out with a control block, or sorry, an event block, when the flag is clicked. Next, I'm going to go back to my pen, and I want to put the pen down. So that's like putting the pen on the paper. And then I need my cat to move. So that's a motion block. So I'm going to say move, and instead of 10 steps, I'm going to make it 100, because I think that'll be easier to see. And now, always before I add too many things, I'm going to test it. Yeah, that looks pretty good. But now I'm realizing every time I stop, I need some way to kind of clear out what was already there. So I'm actually wondering, oh, erase all, that's easy. I'm going to put that at the very start, and I also need a way to make sure my Scratch Cat always starts at 0, 0. So back in the motion section, I'm going to always start at X, Y, 0, 0. So right there, you're bringing in a coordinate plane, which is a complicated topic. Maybe at grade 1 or grade 2, kids won't necessarily fully understand, but you're pulling that in, and through exposure they're going to start to understand it a bit better, so that when we do actually get to the point in the curriculum where we're teaching coordinates, that will make more sense to them because they've already experienced it. All right, now that I've fixed that, let's just test that out. Right, because it's doing it, but it's happening so fast I don't see it. Okay, good. So now that I've drawn one side of the square, I have to turn and draw up the other side. So I'm going to turn by, and it won't be 15 degrees. I know, because I've done this before, that I need to turn by 90 degrees to make that corner of a square. But this is something where students are going to start to learn the properties of a shape and angles. And actually I'm not 100% sure that I'm correct, because sometimes, depending on which way you're going and which way you're trying to make the square, you need to turn more degrees the other way. All right, let's see. And then right after, I'm going to move another 100 steps. All right, so now I have two sides of the square. So I'm just going to keep turning the same direction by 90 degrees. And as I'm doing this, my lovely, brilliant audience, I want you to think of how I could actually do this more efficiently. Grade 6 now coding concept we're pulling in is to make code efficient. So right now I'm not doing this very efficiently at all. But that's okay. All right, I think I have enough sides there. Oh, that's unexpected. There we go. Okay, I did draw a square. So can any of you think of a way that I could take this same idea and still draw my full square, but code it in a more efficient way? Any thoughts? Yes, we're going to use a repeat. So you can see the pattern, again, patterning, another concept in math. Move, turn, move, turn, move, turn. So you don't have to keep saying it. I could actually take this part out, go to my control section, and I'm going to use this repeat with a number. Because I don't, unlike my last project, I don't want to repeat this forever. I want to repeat it 4 times. And now I have this extra bit here that I can just drag over here and get rid of. So if I've done this right, yeah, it still works. Perfect. So now that we know that, how can we take the code where we've drawn a square and now make other shapes? So for example, let's try to make a triangle. How can we modify this code but have it build a triangle instead? There's 2 numbers we'll have to change. First of all, I'm going to change the repeat number. A triangle has 3 sides, not 4, so we're only going to need to repeat 3 times. But if that's the only number I change, when I hit go, it's just going to draw 3 sides of a square. So there's another number I have to change. In this case, it's my angle of turning. So every shape has interior angles of 360 degrees when you add them all up. With a square, 360 divided by 4 gives you 90. With a triangle, 360 divided by 3 should work with 120 degrees. And with students, they often figure this out through trial and error. They don't have to know that mathematical fact necessarily right away to figure it out. But I do often give them the hint to not change this number by like 1. So I don't want to see them putting in 91, 92, 93, 94 and guessing that way. It's going to take them forever. I do often give them the hint of guessing by counting by tens if they're going to be guessing. And let's see if that works. There we go. So there it is. Scratch is now drawing a triangle. Now we can keep figuring out lots and lots of shapes. We could do, octagons or hexagons or any number of any-sided shapes. But what I like to do after a little while that gets kind of fun is to actually work in that concept from the next grade level up, which I think is grade 4. Let me check my paper here. Yeah, grade 4's concept in our new curriculum is nested events. So taking something that repeats and putting it inside of another repeat block. And we can actually make some really cool art that way. So I'm actually going to do something that hides Scratch so we don't see the cat running around anymore. And I think right here, yeah, under the looks blocks, there's one that says hide. So I'm actually going to hide the cat so he disappears. There we go. But we still see the triangle. And then what I'm going to do is add a repeat. Well, I'm just going to do forever. You could do by a certain number. And what I'm imagining in my mind is this triangle, instead of just drawing one triangle, we want to draw a whole bunch of triangles, but rotate a little bit each time to kind of build a pattern. So we want it to build the triangle once, and then I want to turn by, oh, let's say 10 degrees. And for interest's sake, I want to go back to pen, and I want to change the pen color a little bit for each triangle as well. So what I've just built here is a nested event. So see how there's a repeat block and another one inside of it? That's a nested event. Now watch what happens. That's pretty neat, right? It kind of looks like one of those old school screensavers we used to have on Windows XP back in the day, which is cool. So we could get really fancy. And now that I'm thinking of it, instead of repeating forever, I'm going to repeat by a certain number, because we could mathematically try to figure out how many times do we need it to repeat to fill a full circle. So if we're turning by 10 degrees each time, and we know there's 360 degrees in a circle, in theory, we should need to repeat 36 times to go all the way around. And that's true. So now it stops there. So it looks cool either way, and you're learning a little bit of math differently depending on which way you're doing it. But now I'm going to go further deep, and I'm going to nest that. So I'm going to try, I want to repeat maybe 5 times. I want to do all of this, but I want to draw the circle in one spot and then move over and draw it again. So now I'm going to say, oh, I like this block. I just noticed it now. Go to a random position. That would be cool. Okay, so I said repeat 5 times. So it should draw 5 circles of triangles, if what I'm thinking is how it actually behaves. Okay, there's 2. 3. Well, it's acting a bit weird there, but cool. So where it kind of hit the edges, it acted a bit funny, but it really did kind of work how I expected. Lauren, yes, there will be a recording of this, so no worries if you have to take off at any point. Just come back to the YouTube channel later and the recording will be there. So that's pretty neat, right? You can start to do something cool. And that block, go to a random position, is not a block I've ever used before. I just noticed it, which was neat. Now it has me thinking, I wonder if I could have it be so that I can click somewhere on the screen, and wherever I click, it draws my circle of triangles. That would be really cool. Now I'm getting fancy. Now I'm getting into conditional statements, which is the grade 5 concept. Let's see. And there's got to be a way. I know there is. It's whether or not I can figure out while I just thought of it at the top of my head. Okay. I'm going to take these apart. Okay, I'm going to try this if-then block to see if I can use it to draw everything. So you can see there's this little blank, I don't know what you call that thing, little thing there at the top of this if-then. You need to put something in there, and that's where these blocks come in, and you can see they match the shape of that. So they're the only one that can fit in there. And mouse down. Maybe that's the one I need. You know what? I'm not sure, but I'm going to try it. I'm thinking I might have to hold my click for that to work. Well, let's try. Okay. So, in theory, nope, that's not it. But part of me is also thinking it's only checking once if my mouse is down. I might have to put that inside a repeat block too. Don't worry if I'm really confusing you right about now. I'm confusing myself because I'm just experimenting. This is kind of the fun about coding. So once you figure something out, it leads you to think, I wonder if, and then you try something else, and it doesn't necessarily always work, but hey, there we go. Okay, I am holding my mouse down for that to work. So I'm gonna try it again, but not hold my mouse down and just click. Yeah, it works. Cool. So every time I click, it's gonna draw another one of these circles, which is neat. So you can start to see how now I've switched this from something that's just pretty in an animation to something that's actually an interactive application type of thing. And in order to do that, I've jumped all the way from grade 1 concepts all the way up to grade 5 concepts with this. And we also talked about the efficient code, which is a grade 6 concept. So if you've been watching all the videos so far, we've already covered, I hate that word, but we've already kind of gone over all of the things in the new curriculum right up until grade 6. So that's really what it's all about, is just trying things and then extending it. Your brain starts to go to, what could be next? What else could I do? So the one thing I haven't brought in yet is concurrent events. So these are all kind of sequential. It's starting at the top and going through all of this. But I could build something else concurrently. For example, another, when the flag is clicked, I could have some background music playing at the same time. So I could go to sound and play a sound. I don't want the meow, I hate the meow. And you could record like instructions or something, but you can also go to sounds. And I'm just gonna add some funky drums that are quite loud. All right, now I've got drum funky. So it's gonna play it until it's done. But if I wanted to keep playing, I need to put it inside of a loop, a forever loop in this case. All right, so now concurrently, both these sets of instructions are happening independent of each other. Awesome. So every time I click, it's drawing a new little spirally thing. So I'm going to give this a name. I'm going to call it Spirals, for lack of a better name. And I'm going to share it to our studio so that you all can grab that code and play with it and modify it. Because in every grade in this new curriculum, we have two parts, right? You have that top expectation, which is the coding concepts, but you also have that bottom expectation, which is the ability to take code that somebody else has written, or even your own, read through it, figure it out, and be able to modify it, and then try it out and see what, if I change this number, how does that impact what happens? And that can be a very useful skill when something's going wrong, to fix it and debug it, but it's also a very useful skill just for playing around and figuring out, what's the possibilities? What else could I do with this? And then you can also take something somebody else has made, like I've made this for you, and you can take it to the next level, the next step, which is how we end up with better and better apps and, operating systems all the time. They're not starting over from DOS and Windows XP. They're taking that and building on top of it to make it even better and improve it. So that is basically it for what I wanted to show you. But I will open up to questions if any of you have any. And it could be about what I just did, or it could be about anything to do with coding or this new curriculum. And I will do my best to answer. And be honest with me if I like completely lost you with any of this. It's totally okay to say, Erica, slow down. Could you choose something besides music to run concurrently? Yeah, we could. I'm wondering what else we could do. Let's say, for example, that we wanted, if you clicked the mouse, it would draw a circle of triangles, but maybe we could do something else over here. Let's see. I'm going to add a separate sprite, actually. It doesn't really matter what it is because I'm just going to hide it anyways. So we've got our cat, which is hidden. We've got this ball now. And maybe it's going to, or maybe I'll leave it visible just for the fun of it. Repeat forever. Maybe it's just going to bounce up and down. So moving 10 steps is going to move it to the right, but I want it to look like it's bouncing up and down. So I have to point it up to 0. That's convenient that they now have this thing to show me, so I don't have to really know off by heart. And then you're going to have to point back down and move again. So and I liked moving more than just 10 because 10 is very hard to see. And I also know that if I don't put a wait block in here, I won't be able to see it because the commands just happen so fast. So I'm going to wait 0.1 seconds in between each one. Okay, so now in theory, this code with the ball should run concurrently as everything else. And the reason we can't see everything else right now is because right now we're coding the ball, this sprite. If I click back on my cat, I can still see everything over here. So it kind of just keeps things organized for you, but sometimes students will get confused thinking they've lost their work, and they just need to know that you can click back and forth between the two. So let's try. All right, there goes the ball. It doesn't really look very realistic because balls actually don't bounce at a constant rate. There's a bit of an acceleration and deceleration, but there it goes. It's happening concurrently while my little spirals are happening too. So yes, absolutely, anything at all could be happening concurrently, and it can be more than two things. It could be an infinite number of things happening at the same time. Good question, though. Any other questions? It's the benefit of being here live, folks. You get to actually ask things and get immediate answers. I really like the asynchronous way of I've been doing most of the videos. But I do want to do these synchronous ones once in a while just to give people a chance to ask questions. But if ever you're watching the recording of this and a question comes up, feel free to leave a comment below the video or send me a comment on Twitter. And I can always make another video to answer your questions. It just, will take me a bit longer than this instant question answer thing that can happen live. More time to try it. Yeah, that's absolutely what happens. I like videos like this because it lets you see what's possible, but then you're not going to learn it just by watching me do it. You're going to learn it by, sitting there by yourself with Scratch and like dragging the blocks around and experimenting, and then that's when it really sinks in. So Sandy asks, what would your suggestion be in teaching Scratch to students with autism? Sandy, I've taught a wide range of students all over the spectrum, so it's going to depend on that particular student's interests and whether or not they take to something like this. But I've had students with autism who absolutely love this, and I often do something not unlike what I just did with you, where I show them a little piece and have them try it along with me. Sometimes I'm just sitting right next to them. And then I let them kind of dive in and experiment from there. The great thing about the Scratch is there's no right and wrong answer here. I mean, there could be if you're giving a particular problem you want solved, but it's also great just to allow exploration and, drag this block in and see what it does. Do something cool, great, keep it. If not, drag it away, try a different block. So that open-ended exploration has worked well with my students with autism. It might have just been their particular personalities, though. You might try the tutorials with them, but again, it's just really going to depend on a case-by-case basis. Whether they prefer that having the idea and having the structure of the steps to follow along with, or whether they prefer that more open-ended, exploration of things themselves. So I know that didn't really answer your question, but I can tell you I've done Scratch and coding with tons and tons of students with autism, and the majority of them did like it. But it also most of them were boys, and most of them love technology already, so it kind of fed right into their interests. So I guess it depends. But you do have the benefit in Peel, which I know is where you are, of, talking with your ATRT. I have to give a shout out to my former job. And I know a lot of the ATRTs love coding and would love to give some support around this if needed. Yeah. You are welcome. And then as you start trying it, if particular things come up or issues, I'd be glad to troubleshoot with you at the time. But yeah, I would say just dive in, see what happens. All right, I'm just gonna hold on a couple of more minutes just to see if anyone else has any other questions. You're welcome, Carrie. But otherwise, if you've had your questions answered and you're good, that's it for what I'm gonna show you today. So you're free to go. And thank you for making time for this in the summer. It's quite amazing to me that so many people wanted to jump into this, even though I know there are more fun things you could be doing. Although I do find this fun, so I wouldn't be volunteering to do it if I didn't find it really fun. Good, I'm glad I'm not the only one who finds it fun. Well, my friends, we could hang out all day, but oh, here we go. Here's a question. Okay, would it be beneficial to set up a teacher account for students? So I will get to that for sure. I'll make a whole video about that, but yes. This was actually my first time experimenting with teacher accounts, is when I asked all of you to join my class on Scratch. And so I'm kind of learning as we're going through this whether or not it's beneficial. So there are pros and cons to it, I should say. The pro to it has been that I'll actually show you what it looks like on my end as the teacher. So when I'm on Scratch, when I log in, I get this purple bar at the top that you probably don't see yet on your accounts, because yours is just a normal account at the moment, unless you've already signed up for the teacher version. But I can click on my classes, educator resources, or some frequently asked questions there. There's a very limited amount of things I can do with this. But I can see I have 182 students, which mind-blowing. That's amazing that many people signed up. But I see very little about people. I don't even see their real names. I just see their username, whatever they signed up with. But I can go to account settings, and I can either prompt you to change your password. I think it might send you a prompt of some kind, obviously, or I can change your password for you. So in a classroom, you know how it goes down all the time. Anything with a login, when you go to try to use it, Miss, I forgot my password. Miss, I can't get in. So that would be helpful. It's like on the fly, you can quickly change your students' passwords. Obviously, I'm not going to do that to any of you because you don't need me to, but I could see how that would be really helpful in a classroom. And the other thing I did, which was to set up the studio, which is where you can collaboratively as a class publish the things you've done. So you'll see that spirals thing I published earlier is right there. And then you can see each other's code and comment on things. The only other thing I get to see as a teacher is here under activity. I kind of get a summary of what people have been up to, projects people have shared, or if people have commented. I can see those things. So I can't send you messages, I can't send you assignments. It's very limited in that way, but I can see there being some benefit. Now, the flip side to that is I have used Scratch in the past where I've absolutely not used a teacher account at all. I've had students not even have their own account at all necessarily. And you can go to create and kind of mess around like we did today without an account. Don't need one, you just go in, you do your thing. The downside is it doesn't save. So if you end up doing something bigger and more complex, or a student ends up becoming really obsessed with Scratch and wants to make their own games and really complicated animations, more than just the little mini lessons, then they might want an account just for that benefit of being able to save and continue over multiple days on the same project. But if you're just doing these mini little explorations, you could completely start out with no account at all, and then there's no setup and no work ahead of time, which is nice. So I've done it both ways, and I could see people going either way. All right, everyone, I'm not seeing any more questions, so I think we'll wrap it up here for today. I will do another live event at some time this summer. I'm thinking I'll probably put out a few more asynchronous lessons first, and then who knows when I'll do another live. I'm kind of just doing this casually this summer as I end up finding time and feeling like doing it. So we're not on a really set schedule here, but just let me know as questions come up, and if a bunch of questions start piling up, then I can jump on and do some more live stuff. But yeah, thanks for joining me, thanks for coming out, thanks for being a part of this little experiment here with me, and I'm glad some of you are finding it helpful, and I'm sure I will be seeing you again later. Now to figure out how to stop the live stream. It's been a while. I used to do these often, but not lately. Okay, here we go. All right, bye everybody.